Hey Chuck, I want to show you the projected design option on the point constraints, just so that you at least getting that set up right. It's not too complicated, but I just want to make sure that you're really getting that down. Um, okay, so once you get into the corridor modeling, go into the templates. I just set up one just as a little example here. I'm just going to create a new template. Let's call it projected design. So we're in this template, the construction window here. I'm going to just set some steps here just for drag and drop in, just a little precision. And I'm going to go into, just do something just really simple just to kind of show you how it's set up. I'm just going to do an asphalt lane. And I have the mirroring on, so I'm dropping both sides. This. And then I'm just going to merge this. So we've got, okay, just say that's just an asphalt lane, two lanes. And then we'll put a little clear, like a little shoulder in or something. Again, I mean, however you're building this, you're going to build this your way. It just as an example, just zero these out, and then do just a cut slope and a fill slope. Okay, so that's the basic section. And let's say that you wanted to take the subgrade point over here, this lane 1 on the right side here, and then also on the left side, and wanted to extend those out to meet this design surface. If we look at the constraints right now, these are tied to the points above it. So what I'm going to do, just again for illustration purposes, I'm going to go into this point here. Just kind of go in here, and I'm going to change these constraints just to make it a little bit more predictable. And I'm going to change this vertical one to a slope constraint and set the parent to the point here. So that means that it's a 1.5% from this parent point in the center sub to this point over here, and this was a 1.5% side slope on this road. Now the second constraint is where we'll do project to surface, or projected design, sorry. So projected design, and this value here is really just telling it to either go left or go right. So in this case we want it to go left, so that's a minus, and I'll say 200. So go at least 200 feet to the left and seek out and search for this design. And some people put like 1,000,000, or something to really go out there, but this, you'll see, this illustrates it fine. So then apply this. So now the constraints on this side have been changed to a slope constraint. So this segment, this lower subgrade segment, will hold a 1.5%, and then it will project out this point to intercept that design. Once that's designed, I'm going to go ahead and do the same thing here, just a kind of little repetitiveness. Go over to this one. Again, I'm going to change the constraint here to a slope constraint and make the parent this, where the parent before was the point above it. And then it's pulling a 1.5%. I'll set this to project to design, and then on this side it's a positive. We want it to go to the right, and I'll go 200. Apply that. So now that is going to push that way and hold the 1.5%. If we look at the constraints now, we'll see that it has this slope constraint, this little slash glyph along here, and then this little symbol here where it kind of has a line coming down is the way it represents a project to design type constraint. Now, if the way to verify this is doing this, if you go to test, it'll go into this test mode, And if I just do a draw, you'll see that when it goes up here, the component for the asphalt, which we dropped there, is just the same. But when we go down here, you'll see that what it does is it's projecting out that point to intercept the design surface. So that's how the project to design works. So hopefully that that helped you there. Alrighty, Chuck. Just stay in touch, and if you need a little more help, let me know.